Last week, Josh, you left us hanging and we were just getting into some of the most common mounting styles. Can you begin where we left off?
Of course, why not? Let's see, probably the most common designs are the MP1, which is a fixed clevis, and the MP2, which is the detachable clevis. The fixed clevis is part of the cap itself. A detachable clevis is bolted to the cap, and both allow engagement to a clevis mounting bracket with a steel pin held in place with cotter pins or snap rings.
When would you want to use this design?
They're best suited for applications where the cylinder must pivot through an arc as it extends and retracts, such as with a boom crane or a bin tipper. Also, it is important to remember that clevis mounts require attention when being applied. However, because they're highly prone to side load and column strength issues.
What kind of problems can you find with side load and column strength issues?
I'll delve into that a bit later, as that's a problem you can face anytime a system isn't designed for it. For now, let's keep talking about common mounting styles.
Okay, so what's next then?
MF1, this is the front flange mount. MF5 is the front flange extra mount, and the ME5 is the front head flange mount. So all are methods of mounting the cylinder off or part of the head itself. The MF1 has a rectangular flange attached to the head, which protrudes from the side of the cylinder. The MF5 has a larger square flange protruding in all directions, which provides extra strength. The ME5 uses an extra thick and wide head, which attaches directly to the machine. These options require the cylinder to be stationary, and this fixed centerline mounting provides them with a high column strength.
Are there other fixed centerline mounting designs we should know about?
Yep. The MF2, MF6, and ME6 rear flange mounts are similar to the front flange family, except their respective locations are off the cap rather than the head.
Okay.
MF2 has a rectangular flange attached to the head, but protrudes only on the sides. The MF6 uses the same large square flange as the MS5, and the ME6 has a beefy cap containing mounting holes for direct attachment to the machine.
Okay. What about lug mounting? These are some of the more rigid cylinder designs, correct?
That's correct. Lug mounting uses rectangular tabs machined from the same block of steel as the head and cap, although they are sometimes welded on.
Okay.
The 4 MS2 side lugs are on the bottom of the head and cap. The MS3 center lugs are midway up the head and cap, and the MS7 end lugs are mounted to the front bottom of the head and the back bottom of the cap. They are indeed very rigid, but their dual mounting points can add worries of misalignment between the front and rear lugs, especially related to bending or torquing of the mounting surface.
And then we come to trunnion mounting, correct? These are perhaps some of the smoothest moving designs out there?
Yes, the MT1, MT2, MT4, front, rear, and intermediate trunnions are an alternative to the clevis style pivot. They allow the rod to move through an arc as it extends and retracts, although they have a slight advantage in column strength and precision of movement over a clevis mount, especially the front and intermediate trunnions. The rear trunnion is slightly weaker, especially if the rod isn't rigidly guided.
So that's all the common mounting styles then. Can we go back to the side loading and column strength issues then?
Absolutely. An analogy I like to use for when the rod extends toward the end of the cylinder stroke is when you're using a tape measure. If you're like me, you've wasted time discovering how many feet you can get the tape to extend into free air before it bends, dropping with a boing clank sound. The longer the cylinder stroke and the farther the cylinder extends along its stroke, the higher the rate of potential for two common cylinder problems, side loading and column bending.
So what exactly is side loading?
Side loading occurs when a mass or force pushes the rod up, down, or to the side. A cylinder is happy when the in and out forces of compression and tension are applied, but any bending force that causes accelerated wear at best, and a bent rod at worst. When a cylinder is retracted, it has the highest resistance to side load, not only because the torque effect is low when the rod extends a little past the rod bushing, but because the other end of the rod is supported by the piston deep inside the cylinder bore. As the cylinder extends, the moment arm extends as well, increasing the torque potential on the rod, as well as moving the piston closer to the head. This reduces the capacity for the piston to act as a bearing. Side loading also causes uneven wear, as the rod pushes on one side of the bushing and the piston drags with more force across one side of the barrel.
It almost sounds painful.
It is, and it can eventually destroy a cylinder. Column strength, on the other hand, refers to the capacity of a cylinder to resist bending when under compression. This is affected by the distance between the load and the moment, the diameter of the rod, and the class of the mount itself. The distance between the load and the rod can be explained by my measuring tape example. The farther the tape is extending, even upward, the less you can push the tip against the wall before it buckles, or your hand. When a cylinder is mounted at the cap and not prevented from moving around, the column strength is extremely low, and the rod is prone to bending under compression. Because of this concern, the clevis mount cylinder can often operate at a quarter of the pressure as one of the more rigid mounts, such as the MF1 front flange.
So what can users do to avoid these problems in their cylinder mounting designs?
Well, for one, a larger rod diameter improves the strength of the rod itself, which is less susceptible to bending, although the accelerated wear of side loading can still be a problem. The other technique is to add a stop tube, which is simply a tube inserted inside the cylinder around the rod. The stop tube prevents the cylinder from extending all the way, increasing the effect of the piston to share the load and avoid bending. When applying a stop tube, don't forget to subtract the usable stroke length, as every inch of stop tube is subtracted from every inch of stroke. There are a lot of factors to understanding cylinder column strength, but the major tie rod cylinder manufacturers have configuration software that will provide you with a maximum pressure rating for the cylinder you choose.
Well, that's very helpful, Josh. And thank you all for watching. Please visit www.fluidpowerworld.com for more videos.